Hi there. Thank you for watching this clip on domain, range, and inverse functions. In this part 3 of the 3, we're going to give you 5 examples over here. Let's get started right away. The first one, we have f of x is equal to 3 minus x here and plus 3. Okay, so let's take a look at domain. Now remember, domain is what's good. What's good x. Okay. Kind of like a good x, but what good is the x? Well, the function, since it has a radical sign, it requires this inside has to be bigger or equal to 0, which gives us the minus x bigger than minus 3, or x, now remember this dealing with the minus sign, less or equal to 3. Okay, so here's our domain x. X is such that x belongs to the real set, and x is less than or equal to positive 3. Okay, given that, range is all possible y values. Okay, in order for this one to happen, then this chunk is always bigger or equal to 0. So the smallest the y could ever get, smallest y is positive 3. Okay, so let's write it in the set notation. Y belongs to the real number. Y is going to be bigger or equal to positive 3. All right. Now let's find the inverse. We started with replacing y into the equation 3 minus x plus 3. We're going to replace x and y, flip them. Okay. Once again, that's just purely for cosmetic reasons. We're going to solve for y, so x minus 3 squared is equal to 3 minus y. Okay. And then y is equal to 3 minus x plus 3 squared. Okay, so for this particular function, the domain is all real numbers. So let's write x is such that x belongs to the real. That's it. Okay, so there's no restriction on x whatsoever. For the minus 3 over here, minus 3. Okay. So for this particular one, the function, inverse function, is actually flipped over parabola. So with the vertex as 3 and minus 3, 3 positive 3. So all the possible y value is going to be less than 3. Okay, so range y such that y belongs to the real numbers and y is going to be less or equal to 3. All right, this is the first example. Let's go on to the next one. Next one is the interesting one. So I'm just going to speed up a little bit because I think there's a limit on how long the videos can be. All right, so let's get started. The radical sign says x better be bigger than 0. Okay, so that's my range domain. X belongs to R. Okay, range, it's all possible y's. Now, this chunk is going to be at best equal to 0. Okay, and from there it's going to be more and more negative. Okay, so the range is y belongs to the real number. Okay, once again, this chunk is 0. So let's say minus 0. And it can't get any smaller than that. Okay, minus 1. So largest one is going to be minus 1. Okay, graph-wise, this thing looks like shifted to minus 1 and looking down like that. Okay, this is minus 1. So this is y. Okay, let's find the inverse. Y is equal to minus x minus 1. So x equal to minus y minus 1. And solving it, x plus 1 squared is equal to 1. So I moved over there and squared. Okay, so this is my inverse function. Okay. From there, we can see that domain for this one, there's no restriction. it's just x is belong to R. Range is that it's all positive. Okay, so because this one is really just a curve going upward like that. Y belongs to R bigger than equal to 0. Okay, that's the second one. Let's do the third one. I have f of x is equal to x squared plus 1. X is less than 0. Okay, once again, this one ensures that inverse function is a function, the inverse, because otherwise this curve looks like 1, looks like that. Okay, since x is bigger than 0, so this is our function. Okay. Domain is pretty easy. There's no restriction. Belongs to the real. Range, on the other hand, it's going to be everything above 1. Okay, so here's the range. F inverse is relatively easy to find. So we're going to do y equal to x squared plus 1. Y. Let's flip it. So x minus 1 equal to y squared. Y equal to f inverse of x is equal to x minus 1. Okay. Once again, we have the radical here, so the domain forces that x belongs to the real. X minus 1 has to be bigger than equal to 0, which means x has to be bigger than equal to 1. Okay. Let's do the range. So long x is bigger or equal to 1, then y belongs to the real, and y is going to be bigger or equal to 0. Okay, this is the third one. Let's move on to the next one. Let's do a 4, number 4. Okay. Here we have an interesting one. We have a cube root, x plus 3. Now, cube root, unlike the square root, it has no restriction. So x domain is x belongs to R. That's it. Okay, the cube root is one of the odd functions, so it's symmetrical in that shifted over minus 3, so it's over here. The curve looks like that. So the range, there's no restriction on x, so cube root can be positive, negative. So y belongs to the real. Okay. Let's check out f inverse. Y equal to cube root x plus 3 minus 1. X equal to y plus 3 minus 1, x minus 1 cube y plus 3. So it's x minus 1 cube minus 3. Okay, equal to y, which is the inverse of x. Okay. There's no restriction on either one of them because it's cubic. Okay, so x is such x belongs to R. Y is y belongs to R. There's no restrictions on this one. Okay, last one. Number 5. Y is equal to x minus 3 minus 2 cubed plus 1. Again, there's no restriction on this one. The curve is a cubic. The 0, 0 becomes over here, so the curve looks pretty nice and even. Okay, so here's the curve. For this one, domain, there's no restriction, so x such that x belongs to real. That's it. And range is y. Y belongs to real as well. There's nothing restricting it. Let's look for the inverse. So x equal to y minus 2 cube plus 1, x minus 1 cubic root plus 2. That's equal to y equal to f inverse of x. Okay. There's no restrictions, so domain is that x belongs to real, and range, there's no restriction on y either, so y is that y All right. Now, I rushed through a little bit since with the technology, you can always pause it and make sure you get exactly the same thing. Well, I hope this has helped you. Hi, this is Dr. Pan, host of Tucson Math Doc channel on YouTube. As always, I love to hear about your math questions. Till next time, have a confident day.